An awesome lineup of speakers tonight. We've got Nikhila Ravi from Harvard, who's done a serverless GraphQL implementation for Thomas Cook. We've got Nick Graff and Philip Moons from our team from Serverless Inc., who are going to show off a cool serverless framework GraphQL boilerplate. And Todd Berman from GitHub could not make it tonight. He's got a sick child at home. But Brandon Black, also from GitHub, who worked on their new GraphQL API, is here, and he's going to do a great talk over at the end. We'll be ending the night by raffling off this Amazon Echo right down here, so make sure you stick around if you want to enter the competition. And also special thanks to our sponsor, Cloud Academy. They're the ones who bought this Amazon Echo here, so whoever wins, be sure to mention a big thank you to them on Twitter or something. Also, we have a lot of awesome information packed into a short time tonight, so we're not going to do Q&As after each presentation. Instead, we're just going to do one big Q&A at the very end of everything for anyone who really needs to ask a question and is willing to stick around. So let's get it started. Our first presenter traveled all the way from Boston to be with us tonight. You may have seen her serverless architecture in the Wild presentation at NodeConf in London. Please give a warm welcome to Nikhila Ravi.
Hi everyone, I'm really excited to be here and talk to you about serverless GraphQL. So just a really quick overview of my background. So I studied engineering at Cambridge, and then I did a coding school in London called Founders and Coders. And since then I've been working as a developer with an organization called Will, and now I'm studying at Harvard for a year as a graduate student. And I want to talk to you today about three things. So using AWS Lambda, API Gateway, and GraphQL together to build serverless applications. I also want to share some of the lessons that we've learned and some of the tips that I can give you from having implemented a serverless GraphQL application. And lastly, I want to share some other cool things that I've come across. So earlier this year, I worked on a project with the Thomas Cook Group to implement the next generation holiday search platform. And for this, we were using a completely serverless architecture. And in particular, the interesting thing about this application was an API facade, which was built using AWS API Gateway, AWS Lambda, and GraphQL. So just to get an idea of everyone's background, who's used Lambda before? Give me a show of hands. It's quite a lot of you. The API Gateway, and what about GraphQL? Okay, so slightly few of you use GraphQL, but so I'll quickly run through the basics of Lambda, just for those of you who haven't come across it before. So AWS Lambda enables you to use functions as units of deployment. So individual functions can be deployed as Lambda functions and triggered by events. So this enables a microservices architecture to be realized in the cloud. And AWS in particular have made this really appealing by having a pay-per-execution model and a really generous free tier, which makes Lambda really easy to access and very cheap to play with. So this is just an example of a Lambda function. So the important things to notice here are just how it can be invoked with an event, a context, and a callback. So Lambda by itself is really exciting, but it gets even more exciting when you pair it with the API Gateway. So the API Gateway enables you to expose public HTTP endpoints, and these endpoints can map to Lambda functions. So API Gateway is also really exciting in that it has a pay-per-call model and a really generous free tip. So at Thomas Cook, we were using API Gateway and Lambda together with GraphQL. And so GraphQL is an application-level query language that was developed by Facebook, alternative to a traditional REST API. And the really useful thing about GraphQL is this idea of a schema. And the schema is a model of the data that can be accessed from this GraphQL server. And then the key advantages of GraphQL are firstly that there's client-specified queries. So the client requests exactly the information that they need, and the server only returns that information. So there's no overfetching of data. And it also enables multiple data sources to be queried within a single query. So you only have a single trip to the server. So you can fetch data from multiple sources within a single query and a single trip to the server. There's some other also interesting things like introspection, which enable the API to be self-documenting. So these are the three technologies that we were using. But instead of deploying GraphQL as a server, the interesting thing that we did was to deploy it as a Lambda function. So the entire API for this application was accessible through a single endpoint / GraphQL. So no matter how many different backends your application uses, the client only ever needs to be aware of this single endpoint. So just to give you an idea of the structure of the application, the UI was a static website, which was hosted from an S3 bucket. This then made requests to single endpoint in the API gateway, which would then trigger this GraphQL API facade Lambda function. And this GraphQL Lambda function would then distribute the data fetching to multiple other microservices, which were each deployed, again, as separate Lambda functions. So GraphQL really acts as this API facade. It distributes the data fetching based on the query, aggregates the responses, and then sends them back to the client. And each type in the GraphQL schema has its own resolve function. So the resolve function can map to a Lambda function. So each of your types can fetch data from different sources by distributing the data fetching to multiple other microservices, which are each deployed as Lambda functions. So this enables a really modular application by AWS Lambda. So to give you an idea of what all this actually involves, so I understand it's quite abstract, it's quite hard to get your head around it. I built this GraphQL serverless Jukebox, and I want to show you how this works and how a query flows through this application. So it's really simple. It's just a jukebox. You can search for songs, add them to a playlist, and you can save the playlist. But this breaks down to a really interesting architecture, which I want to walk you through. So the UI is, again, just a static S3 website, for which I use React. This then makes requests to the single endpoint on the API gateway / GraphQL, which maps to a GraphQL Lambda function. This is the API facade. So there's multiple other microservices that this Lambda function can delegate to. So there's an API, there's a microservice which gets songs from a third-party API. There's another microservice which saves songs to an S3 bucket. There's another Lambda function which retrieves songs from an S3 bucket. And this GraphQL Lambda function is what delegates the data fetching delegates the other microservices based on what's requested by the client in the query. So I'm going to walk you through the path of a query through this application. So the client makes requests to the API endpoint, which then triggers this Lambda function. And when this Lambda function is triggered, the information from the client is sent in this event object. So specifically, there's a query, and then there are variables. And these are then resolved against the GraphQL schema, which you've defined. So this is the schema. And what does the schema look like? So for my application, the schema has two areas. It has a query, which are like GET requests. So I can ask for song suggestions, and I can also get my playlist. And then there's also mutation, which is like a post request. So I want to add a song to my playlist. So taking a closer look at this suggestions query, the suggestions query has a type. So here it's a suggestions list type. And this type has several different fields. So I can get the name of the song, I can get the artist, I can get the URL, or I can get the image URL. And this is the sort of structure of the data that can be fetched. And this type also has a resolve function. And this resolve function maps to another Lambda function. So whenever I request data of this particular type, it then triggers another Lambda function. And here, this Lambda song suggester makes requests to a third-party API to retrieve song suggestions. So if I was to send a query to ask for song suggestions, and in particular, I just want the name and the artist, and I send as query variables purple, and I say I only want 4 songs, my response would look something like this. So the shape of the response exactly matches the shape of the query, and I get 4 responses, and I only get the name and the artist. It's very declarative, you don't overfetch data, and it's very easy to reason about. So one of the other cool things about GraphQL is it comes with this IDE called GraphQL. So it's a really useful developer tool. So you can explore the schema, build up different queries, and then see what the actual returned response looks like. So we really think this is a new way of building serverless APIs. So in particular, you can have a very complex architecture, but the client is only ever aware of this single endpoint. And they can fetch all the data that they need in a single round trip to the server. So what are some of the good parts of using a serverless GraphQL architecture? So firstly, you can deploy each function individually. So the microservices architecture makes it really modular and really easy to update functions individually. You can keep all your microservices really simple. So one Lambda function that gets songs from the third-party API, that's all it does, that's all it has to worry about. There's also some other benefits of using Lambda, namely the pricing model and the free tier. So what are the slightly scary parts of the things that you might have to worry about? So having this microservice architecture makes it really modular, but it also makes it very hard to debug things. So you have to follow the path of the query and figure out where the error is. That becomes really difficult as the number of moving parts in your architecture increases. So you have to be very careful about having good integration testing, and also you might have to start worrying about latency issues if you have, say, multiple Lambda functions that are executed in series. So some tips. So how do you tame your microservices? So we had a separate repository per microservice, but this can get quite difficult to manage, especially if you have 10, 20 different microservices. You have to hop between different repos, so that becomes quite complicated. We also need to make sure that you document interfaces really clearly between microservices. So what are the shape of the, what parameters should I specify in the event object to invoke a different Lambda function? All these interfaces need to be documented really clearly. We also had to have separate deployment scripts, so we didn't have to manually deploy to AWS, and also make sure that we had local invoke scripts, so we didn't have to deploy to AWS every time we wanted to test something. So these are the difficulties that we faced without using a serverless framework and doing everything ourselves. So if you want to learn about AWS, we also actually created some resources. So if you're interested and excited about this, go and learn about AWS Lambda for those of you who haven't already learned about it. And we also actually created lots of resources to help with deployment and testing, so you can have a look at those too. So that's just a very quick overview of serverless and using AWS Lambda with GraphQL and the API gateway to build a serverless application. I just wanted to end by sharing some other cool things. So how to add authentication to your GraphQL, a serverless application, and also at the end I want to show you an example of why I think GraphQL is so powerful as an alternative to a REST API. So firstly, authentication. So if you're building a REST API, you obviously want to make sure that users can only access things that they are allowed to access. And with GraphQL, this becomes really easy with the addition of this viewer parameter. So the viewer is something that's accessible in all of the GraphQL resolve functions. So you can pass in, for example, here, an authentication token from auth0. So inside my resolve function, I have access to this viewer object, and then I can check, does this viewer have permission to retrieve that playlist? So I can very easily add authentication to a GraphQL API. It's on GitHub. If you want to go and have a look, check it out, try it out for yourself, and submit issues and pull requests if you have things you'd like to add. So lastly, I just wanted to share something that I built last year. And it just gives a really good example of how GraphQL is really powerful. So when Austin invited me to come and speak, he mentioned that GitHub are releasing a GraphQL API. One of the projects that I built when I first learned how to code, and it was built on top of the GitHub API. So I'm just going to really quickly show it to you. It's called Code Crystal. And the problem we were trying to solve was whenever you're looking at someone else's code or you're trying to review someone's code, it's quite hard to figure out what are the important files in this project, or what files should I be looking at, and how do different files link to each other. And so I built this up with a couple of friends, and what it does is you say which repository you're looking at, who is the user, and who's the owner, who's the repo, and what branch you want to look at. And it creates this interactive map of all the files in your repo and how they're linked to each other. So these are all the NPM modules. You can see this is the server, and the server requires all these files. It's a very simple application. All it does is get the commit from your repo, get all the files in that commit, and then the contents of each file, and then we just pass the files to look for module.exports and import. It's a very simple application built on top of the GitHub API. But making calls to the GitHub API can get really complicated. So here, I dug out this code earlier today, and I was looking at it, and as you can see, there's so many nested callbacks. So there's the first function gets the latest commit from that repo. The next function gets the list of files in that repo, and then the next function gets the contents of each of those files. And if you have, say, 100 files in your repo, that's 102 individual calls to the GitHub API, which can get really inefficient. But with GraphQL, you have the power to turn this into a single request and a single GraphQL query. And you don't overfetch data, you just get the data that you need in a single query in a very declarative fashion. So I think that GraphQL really has the power to transform the way APIs are built. So if you want to have a look at the code for that app, it's also on GitHub. It's just a pet project that I really wanted to share. So yeah, that's all I wanted to talk about today. If you want to have a look at any of the code, it's all on GitHub. And you can send me a tweet if you have any questions. But yeah, thank you very much.
Thank you, Nikila. That was a great overview of not only Lambda API Gateway and GraphQL and some great use cases and examples. Next up, we'd like to bring Philip and Nick team members at Serverless here up to the stage to talk about using GraphQL with the Serverless framework.
So hello everyone. Yeah, we are Nick and Philip, and we would like to talk about serverless and GraphQL today. And we are also announcing a very cool project, the serverless boilerplate or starter kit you can use. But before we jump right into this, I would like to give you a quick introduction about the serverless framework and what the serverless framework basically is, because this starter kit is based on this serverless framework, and why you should use it. So let's imagine we would like to build an authentication system. So for example, we would like to provide functionality so that users can log in, can sign up, can recover the passwords and stuff like that. So if you would like to move this to a serverless application and benefit from all the stuff you get from Lambda, you would basically write your code, for example, the code to sign up the user. Then you would zip up this code, you would upload this code to an S3 bucket on AWS, and then you would specify and set up the infrastructure which should trigger this Lambda function. So for example, you would set up an API endpoint, an API gateway, hook this up to your Lambda function, so each and every time someone triggers or accesses this API endpoint, your Lambda function will be triggered. But this way, from your basically your authentication microservice, you only have this login function implemented yet. So you would like to, or you have to do this for the sign up function as well as this process. So write the code, zip it, upload it to S3, set up the infrastructure so that your function will be triggered, and you would do this the same step again for your recover password functionality and stuff like that. Upload profile photos. It's really a tedious process because you would like to, or you have to do this manually each and every time. And there are many other different problems and challenges you have to, or you face when you do this that way. And those are basically, for example, how would you manage multiple Lambda functions as a whole service? How would you work with team members on your project? What about multiple regions and stages you would like to deploy to, for example, the production stage and development stage? And what about code sharing? Because some of your Lambda functions might share a common code base. And what if you would even like to deploy, for example, to Google Cloud Functions or IBM OpenWhisker, stuff like that? And yeah, those are the challenges you will face if you do this manually. And lucky enough, serverless has you covered. So we basically created the serverless framework, and with the serverless framework, we think in services. So, for example, the microservices, like I already said in the user microservice case, we have, for example, a resize picture function. So each and every time a user uploads a new picture, this picture will be resized. You would maybe also have a reminder function. So on a, for example, every 2 hours, the user will get a reminder, or even if the user wants to sign up, we have a create function. So you bundle all those functions inside of a directory, you write the function logic. All you have to do is install serverless, which is an npm package. So it's a CLI tool, you install it, and then you just drop this serverless.yaml file you see here inside of your service, and then you just have to specify for each function which event should be used to trigger this function. So for example, we have here the resize picture function. You wrote this code for this thing, and now in the serverless.yaml file, you simply say, okay, this will be triggered each and every time a picture will be uploaded in the picture S3 bucket. And for example, we also have the reminder function here. We wrote the code, and inside of our serverless.yaml file, we simply say we would like to have a scheduled event, and every 2 hours we would like that this event triggers our Lambda function. And the same with the create function here. We say, okay, we would like to have an HTTP endpoint, and every time this endpoint is visited or data is sent to it, we would like that our handler users.create is triggered, so our function is triggered. And then the only thing we need to do here, we have written or wrote our functions and have dropped this serverless.yaml file inside of it. We just run serverless deploy, and serverless will pass this file and understands what it needs to do to set up the whole infrastructure. So it will set up, for example, the S3 bucket for you. It will set up the scheduled event, and it will also set up all the API gateway stuff for you, so that you have a post endpoint which is available under /users. And this is really powerful because now you have only to focus on your functions and your function code, and you can just run serverless deploy, and everything is up and running in a few seconds. And Lambda was basically started, or when Lambda was started, the main purpose of Lambda was data processing. So let's imagine we are Netflix, and some movie studios upload a file to an S3 bucket, then we can utilize Lambda to process the video file, for example. And this was a very common use case for Lambda, but nowadays, because of API Gateway, we have the possibility to basically create a whole web application which runs completely serverless. And we've seen many different architectural patterns users use. So for example, we have the microservices architectural pattern, which means you have one job per function. So for example, log in, sign up, recover passwords, and you have one endpoint which will point to this function. Then there's also the services architectural pattern, which means you have some related code, multiple related jobs per function, and multiple endpoints which will point to that. Then you have the monolithic one, and this is a really interesting one. You basically put everything inside of one Lambda function, and you have multiple endpoints which will point to that. And the other one, which arose, was the GraphQL architectural pattern. And this means that your GraphQL is inside your Lambda function, and you have one endpoint, which we already saw in the previous talk, and now your Lambda function manages the data fetching for you. And I would like to hand over to Nick, who will just show you now the GraphQL boilerplate and explain this to you in detail.
Hello, everybody. So I want to introduce you to how to combine them, how to use the serverless framework and GraphQL together. And let me quickly recap. So what we want to do is we want to have this one endpoint that gives you all the power of GraphQL and combine it with an easy deployment. And because we started to use GraphQL and serverless for building our platform a couple months ago, and we really figured out we love it, it's amazing to use, we actually wanted to share this with you. And so what we did is we extracted from our current application and starter kit or boilerplate that allows you to take this thing, clone it, do like a couple minute setup stuff, and basically deploy it up in production. And I find this, I'm super excited about it, because if you use GraphQL, I mean, there's a couple of templates out there or starter kits, but then you use Express, then you again have to deploy it somewhere and you don't know how it scales. But the power of Lambda is that theoretically it scales indefinitely. And so you can basically set it in front of every REST API or your data backend, and it just runs and it works really, really well. So we extract this from our current application, and you can take this and deploy it. Let me tell you a little bit about the features so you can get a feel of what's in there and what we share with you. As already mentioned, it's production ready. Just take it, deploy it. But what we learned on the way is it's really useful, especially for UI development, to have kind of an offline setup where you actually use mock data. And so we built this into this boilerplate. So you can run this in two ways. You can either run this with npm run start remote, and then it will actually invoke the remote database or whatever database you set up there, or call different lambdas. That's what we do. Or you can just mock the data locally. And this allows you to go into edge cases for UI development and makes it really, really fast and easy to develop. It's all based in Node, so it uses GraphQL.js. Obviously, it uses serverless, React, Recompose, CSS modules, Webpack, Jest, all the fancy new stuff that we use nowadays. But it comes in two versions, and that's the best part, because there are two major JavaScript clients out there for GraphQL. For one, there's Relay, built by Facebook, and the other one is Apollo, built by the Meetup team. And both are really awesome. Both have their up and downsides, but I highly recommend to check them out. And I want to thank the Apollo team a lot for contributing to this, so that you actually can get started with both versions. All right. Now that I have your attention, I want to walk you a little bit of the structure and explain how it's set up. It basically consists of 4 directories, which is the API directory, the app, foundation, and GraphQL. And I get started right away with the most interesting part, the GraphQL part. And that's pretty straightforward, typical GraphQL setup. In this case, we use Relay. So you have this node.js, which basically is a node structure, node file, JavaScript class that you inherit as an interface. It has the schema, and the schema is the core. The schema is the part that you share between backend and frontend, and the schema is the one that allows you to do all the cool magical stuff with GraphQL. It has the type system, so you can create your types as we already have seen in the previous talk, in this case also utils. And types look exactly the same. The only special thing we have in the setup is that instead of directly calling lambdas, what we did is we basically wrapped database into, it's just a JavaScript module which exports all the functions to fetch your data. And in this case, we import from the database this module and say get viewer, for example. What we did here is, based on your environment variable, how you start the setup, we use either the mock database or we use the database where you fetch the stuff from probably your lambda. And yeah, this is basically how this is super simple and straightforward. This is how your mock database looks like. So you can do whatever you want in here. And in our case, we create a couple of things and show them, and even like based on setup, you could create different kinds of data setups. The next part, the second of the 4 directories, is the API folder. And this is super simple and straightforward. This basically has 4 files. It's the handle.js, the shrink wrap, just to make sure you always get the right modules, package.json, and serverless YAML. And the handler is, again, basically what we have seen in the previous talk, just a handler to get the body from the event, from the HTTP event, the API gateway, take the query, take the variables, pass them to the schema, GraphQL, and GraphQL does all the magic with the resolve functions. Package.json, super slick and simple. In this case, we just have bubble polyfill, GraphQL relay, JSON web token. If you need authentication, but if not, you can actually drop it out. So very slick setup, and this actually helps a lot to speed up the cold starts of your Lambda functions. And last but not least, serverless YAML. And the only thing you have to do to set up an HTTP endpoint with this GraphQL handler is basically say that the handler file has a GraphQL method. You specify it with the handler. Takes an HTTP event, which the path is GraphQL. It's a post method because a GraphQL, you can run GraphQL with get, as far as I know, but I've never seen that. Usually it always takes post, and I highly recommend that. And of course, you want to set up course. And that's really convenient. You just have to take course true, and it already serves the options pre-flag request and sets up the correct headers. Last but actually the second last is the app, and there's also, this is just a simple React application. There's nothing special here. The only thing that might stand out is that you can see in the router, because we use Relay, in this case, we have to apply the router middleware. And that gives us the benefit that we actually pair route, can define what queries to fetch. But if you use Apollo, it looks a little bit different. It's actually really straightforward and not too hard to do. Our foundation, and this is where we keep all the magical stuff that you don't need to know much about. It's a dev server which runs on local host. If you start locally, it has some in the GraphQL part, you have some tooling to set up regenerate the schema. The chest part contains mocking for CSS modules and other stuff, but and also the webpack. So we have a webpack set up for production and for development, and yeah, so far so good. All right, so how you can use it? For once, you can simply do npm start, and check it out, run npm start, and it will just run on localhost. And as you can see in this case, it initially the initial setup or the boilerplate just fetches the viewer with its name, and you can see the GraphQL request being done here. And in this case, our user is Ada Lopez. But the part where I'm really excited, actually can run npm run deploy, and there's like 1 to 2 things. You have to set up a unit bucket up front and replace the code in 2 steps, and then you have to deploy the thing. But like if you have done that, then like every time you run npm run deploy, you basically get this free, really powerful production version of your GraphQL endpoint. And I find this really amazing. Yeah, just run it, it deploys, and in the end, you're up and running and have GraphQL in production. So when can you use it? Because it's, for one, it's really cool to use it for a new, and not having a new projects every day. So what I've seen a couple of times, and what I highly recommend you to do, and why I think this is actually might be useful to you, is you can actually use this for new applications, but you can also use it to grab your existing REST API. Because what you can do is you can take this thing, deploy it, and this thing scales because it's AWS Lambda. So you can take this, grab your existing REST API, and just deal with it, and then demonstrate to your coworkers, to your CTO or whoever, that you actually can build an interface on top of your REST API that is queryable, so it becomes more efficient. You only fetch what you need, and it's way easier to use, and it can use all the amazing stack that like we gained over the last 1 to 2 years in JavaScript with React, Relay or Apollo, Jest, all the cool stuff. And I found this super exciting. I'm lucky that I could work on a new application, but I've seen a couple of people being super happy just wrapping the REST APIs and then having the benefit of GraphQL in the front end. And that's it so far. Thank you very much.
All right, thanks, Nick. Yeah, those were some great examples of serverless and GraphQL. I just want to take a sec to explain why we're so excited about it, why we're doing all these GraphQL experiments over at Serverless. It's just because it's all about efficiency to us. It's all about lowest total cost of ownership. That's what attracted us to Lambda at the end of the day. It's zero administration, pay per execution, microservice, event-based compute service that automatically scales for you. I mean, that is super darn efficient. Then I remember like 9 months ago, when I was just going through this phase of trying to put anything I could into a Lambda function, this guy, a friend of mine, Kevin Old, came to me and he said, have you checked out GraphQL? It's so cool. You could take a REST API with a whole bunch of endpoints and consolidate it into a single endpoint. And you only have to maintain that one endpoint. But he said, if you put this into Lambda, this serverless compute service, it's like it just doesn't get more efficient than that, we think. So we're continuing to play around with it. We're going to do a lot more in this direction. But I'm super excited for what the future holds with this type of compute service in the cloud and this new type of query language. Anyway, that said, I'd like to welcome up Brandon Black, a senior engineer on the platform team over at GitHub, to talk about the new GraphQL API over at GitHub. It's pretty exciting to see someone, a bigger company, put it into production at scale. So that said, here's Brandon.
Thank you. All right. So, full disclosure, I found out about this about 6 hours ago after Todd couldn't make it. So I'm not as exciting as Todd. I'm not as funny as Todd. And of course, I don't have a great slide deck yet. So, but I want to talk to you guys a little bit about what we built at GitHub and recently announced at Universe. Some of you may have already heard it, may have already used it. But we recently built a GraphQL API that we released to the public. And it also leverages some things that we're doing internally. Tonight, what I'm going to do is just talk a little bit about the motivations that were behind that move, why we're even dabbling with GraphQL and kind of what we're thinking. And then also, I'll just talk a little bit about some of the challenges we faced, still do face, and some of the things that we're working on in the near future. So first things first, I'm Brandon Black. I've only been at GitHub about 7 months or so. I came in March. Prior to GitHub, I worked at Twitter, also on APIs. I worked at Facebook, MongoDB, and really long time ago, I worked at MySpace on the development platform. Yeah, as you can it's not on MySpace account. So this is the beautiful team at GitHub that brought you the GraphQL implementation that we currently have. It is a great group of folks. And basically what happened is in March, for a few reasons that we'll go into in just a minute here, we started playing around and kind of spiking with a prototype of kind of what an internal interface would look like for the platform. The platform team is the same team at GitHub that handles high availability, infrastructure, search. We work on the current REST APIs. And effectively, we were trying to deal with some internal scalability problems, some long-term milestones that we had, and we saw a very clear need to effectively form this interface between everything on the front end of GitHub and everything on the back end. GitHub, as you probably know, is a giant monolithic Ruby application. There's other stuff in the stack too, but the bulk, the core of the app that you guys all use every day is just Rails, a massive Rails app. And, to a certain extent, the writing's kind of on the wall about that as a long-term strategy. Diversify other tech stacks, other data stores, be able to silo things out into services. When you get to a point where you can take a thing that's struggling to scale or a thing that's being tossed and scale it independently of the rest of the product, it gives you a lot more flexibility and makes solving those scalability problems easier and more manageable. So for us, GraphQL is kind of a step in that direction. Internally, it allows us to create this interface for everybody internally to use. And it wasn't really very difficult for us to see the value proposition for making this an external thing as well. So I'm actually glad that Michaela talked about the REST API, because that's one thing we're going to cover as well here. So getting data on the REST API often requires many requests, like Michaela was demonstrating. Almost everything is hung off the repository at GitHub. It's kind of the central part of the data model that everything relates to. So when you're making a bunch of stateless requests to a REST API to get a number of hybrid number of objects from our backend platform, we effectively have to make a lot of extraneous calls to the database. You have to make a lot of extraneous calls to the API, and it's suboptimal for everybody. It's also difficult to release, any kind of really big change to the REST API. Sometimes managing that is difficult. GraphQL gives us a couple advantages there, and then it's also like they were saying earlier, it's easy to overfetch data. Not only for us making tons of SQL queries on the back end, but for you, let's say you're building something like Travis CI, and all you need is a repository status, and you have to go fetch this entire repository object. It's both inefficient for you to fetch that and inefficient for us to serve that to you. So a lot of good motivations on the REST API side. The other side of it is that we use our own API for integrations previously, the REST API, things like Hubbot and everything else. But we weren't actually building features on them. So the REST API kind of suffers from the same problem that everybody's REST API suffers from, which is that feature parity is very rarely there. Things get built in the product, and then someday they trickle down to the API where the rest of developers can build on top of it. And that was always a pain point for us as well. Internally, like I said, we actually built this with an internal focus first. We did our initial spike back in March or so. And then we stood up an endpoint just for staff to play with. The first version of this, we just basically dark shipped a few small features on GitHub quietly. Nobody noticed. But we dark shipped a few small features built with a GraphQL backend just to see how it worked and how it played for us. And then we had a post endpoint set up, api.github.com/GraphQL that we played around with as staff. And it wasn't long before we were like, why don't we release this publicly? And we decided to make the effort to do so, and that was what one of our big announcements at Universe was. So one of the common questions we get is, why GraphQL? Why not thing X, some other thing? And the truth is, we actually did look at a number of things when we were evaluating GraphQL initially. But the thing that we liked about GraphQL was, one of the things that we liked about it was that to us, the value proposition was really clear. It solved a lot of common problems that are both internal problems and external problems when you're thinking about an API or any kind of a platform implementation, and things like being able to make a very complex expressive request. We love the fact that you get nothing back by default. You have to declare everything that you need, which means we're not serving you too much. You're not just cargo culting a bunch of data from the database. So it's good for everybody. And the spec itself is very unopinionated. Some of the other things we looked at didn't really. They had a little bit too much influence over the actual implementation. What we liked about GraphQL was there was a very lively open source community behind it, and at the same time, the spec itself was very unopinionated. I remember internally when we first started talking about this, I think somebody said, "Isn't GraphQL a Node.js framework?" And that's true, it is, but it's also this really great thing. There's obviously a lot of support in the JavaScript and Node.js community, but what we built on the back of some really great open source maintainers in Ruby and other languages, and GraphQL has a ton of support and just a very lively, great community. So one other thing that we really liked about this was that it's an opportunity for us to collaborate with the community. GitHub being the home of open source for about 80% of the open source projects, really most of the open source projects in the world. Oddly enough, we don't really get to contribute that much to really big parts of the open source community. Obviously, we use things like Rails, but at the moment, it's an internal kind of customized version of Rails. We're stuck on an older version. Working our way off that as well, but it's kind of hard for us to throw back contributions to the community when we're not on the same version that most of the community is using. So one nice thing about GraphQL that we liked was that this was something that not only solved a lot of really practical problems for us, but it gave us an opportunity to jump in and actually contribute back in a variety of ways. One of those contributions came hot on the heels of our API announcement, which was the GraphQL client RubyGem, which is a Rails front-end client for consuming a GraphQL backend. And we used that on GitHub.com and released it free for everybody else. And it's a really great library, really great first kind of contribution from us. Hopefully there will be many more. But obviously, like one of the other real big things that I kind of already alluded to is it just paves the way for greater diversity in our tech stack. We have a need for other types of data stores, other types of code and various frameworks. And long term, it doesn't make sense to keep kind of betting on that growing monorail. We joke internally. I probably shouldn't say this. We joke internally that we're doing God's work and we're helping break up that monorail. But it obviously has some very clear benefits. Microservice is a dirty word at a lot of companies, especially bigger companies that have to deal with things at large scale. But the reality is that the larger that big single application grows, things like deploy time, like CI, like keeping your tests green, those things get really painful and end up consuming a very large amount of your day. And if you can break down that problem into a more manageable scale in small services specialized to do what they do to the absolute best, it's a win for everybody. The big thing that I liked about this actually is it was actually kind of a cultural change for GitHub internally. The way we ship in a lot of ways, effectively making the API endpoint public and making everyone internally build on it, we effectively made the API a 100% first class citizen at GitHub. Features go into GraphQL before they can be built on the website. So there's never this feature parity lag. It's 100% about GraphQL, which is amazing. For example, the new projects feature, the project board that GitHub announced, that's built entirely in GraphQL on the web UI, and it's also available in the GraphQL API. And the REST API, where it's available as well, is backed by GraphQL. So not the entire REST API, but at least that feature. So some challenges creating Keynote slides that animate in the right order. Some challenges that we had to deal with were things like multiple schemas. Obviously, one thing we don't want to do is accidentally leak a new upcoming feature accidentally too early via introspection or via just schema tidbits that you guys would see through the GraphQL API. But we're working on everything in there first. So we had to come up with a way to actually split the schema between public and private objects. And at the same time, there was a ton that we wanted to share. We didn't want to maintain duplicate schemas. So this was actually kind of an early headache that actually I personally tackled, and it was very challenging. The good news is, I can tell you at least right now, there's literally only I think 2 objects in the entire schema that aren't public. So it's kind of cool. I like the fact that we're kind of throwing everything out as early as we can. But this was a huge headache. So privacy and security, also a big headache. Very easy to do things incorrectly and accidentally leak data through a connection, or just not realize that you can go fetch this thing through some adjacent part of another object in your query and expose it incorrectly. Expose like a user that's been flagged for spam or something like that. So that's been very challenging. We have some cool stuff there that I hope we can actually open source at some point. But we've created some things internally to kind of give us a heads up if this might be happening early on in development. Basically crawl every possible query you could ever make across the schema and try to look for anything that might be leaking or potentially sensitive or incorrect. Performance is another thing. So one of the big advantages that I forgot to mention in the earlier slide is that with the REST API, let's say you're fetching the repository status for 10 repositories. The way the REST API works now, that's 10 requests to the database. For us, with the GraphQL API, we can actually batch these things together. We use a promises implementation on the back end, built actually by the guys at Shopify. And it allows us to basically take all those things that you're touching in your giant fact wave of GraphQL and turn it into, in the best case scenario, a single hit to the database. So there's a lot we're doing on the back end, and now that we have this in place to try to change the way we did things before, maybe things in the model layer, and provide some additional performance. We don't really have anything we can share actually yet in terms of what kind of performance gains we've got. But I will tell you that pretty much across the board, it was at least as good as what we were doing before, and usually a little bit better. But there's tons of ability to improve that. One of the other challenges that I would say is onboarding. It's obviously, and I say this thinking of both external and internal developers, it's obviously a kind of a mind shift from what everybody was doing before, thinking about RESTful APIs. If you're new to GraphQL, it might be a little bit intimidating. I can promise you once you get into it, you'll see the value proposition very clearly and very quickly, I think. Everyone on the platform team that worked on this implementation, almost everyone actually, sans Todd, had no experience with GraphQL prior to this. Even in my time at Facebook, I was there before GraphQL, so I had no exposure to it. But it was really quick to actually hit the ground running and produce something and really quickly see the value of what we were building. Some things that we have coming, kind of a common question we have is, will this replace the REST API? Maybe, that's kind of the dream, right? That you guys get features exactly the same time that we get features, that we build features in the schema. But we don't really have a timeline for that. What we have now is public alpha. We're releasing to you the exact same code that we build on internally, and just seeing what you guys do with it and seeing how well it works for everyone. Some challenges there are things like OAuth scopes and permissions. What you'll probably see in the next, before we exit the alpha stage of this, will be you'll probably see a rework of permissions on GitHub, period. You'll see maybe, hopefully, a unification between what we're doing in OAuth and integrations and GraphQL to make it maybe more granular and something that makes a little bit more sense for everybody. I think it was mentioned earlier that GraphQL is usually not done via a Git endpoint. You actually can make a Git request to the GitHub GraphQL API, and what it'll do is it'll dump the schema. So you actually can just curl the schema easily if you just want to look at a schema without building an introspection query. But otherwise, it's just a simple post endpoint to maintain, and a lot of code reuse, which is really great. A lot of the stuff that's coming up in the next 6 months or so, you'll see. I think you'll probably see a lot more, hopefully a lot more public code that we can share with you guys. Like I said, we're experimenting with things like doing security analysis on queries, experimenting a lot with performance. We're also experimenting a lot with kind of the developer experience of building on GraphQL as we're documenting and building on this thing internally. So I'm sure you'll see a lot shake out of that. And I would encourage you to follow along at gitobengineering.com. There's also a really great blog from Garin, one of the members of the team. He wrote a great blog about kind of the motivations and some of the details behind what we built and why we built. I would definitely encourage you to go read that. It's a good read. And then you're welcome to harass me on Twitter and ask me questions. Also, if you haven't signed up for it already, here in SF, towards the end of the month, there's a GraphQL Summit, the first ever GraphQL conference. Happening over in the Dog Patch, and myself, a bunch of guys from Facebook, Meteor, Shopify, will be talking there. So definitely encourage you guys to check it out. But overall, it's something that I think internally at GitHub we're very pumped about it because it's problems internally, solves a lot of problems externally, and it's got some new and interesting challenges, which is fun. But overall, we think it's been a huge boost for everybody. So, cool. If we have any questions, I guess we can probably do it as a group Q&A afterwards, I think is the plan. But otherwise, happy to talk to anybody. So.
Thanks, Brandon. Awesome presentation. You and your team at GitHub are clearly trailblazing. I think you're going to have a huge impact for this whole project. Okay, so now the moment you've all probably been waiting for is we're going to give away this Echo over here. It looks like it comes in a silver color now, so that's pretty cool. Anyway, so we have a serverless Raffle application that we built. It's open source. I think it's available on our GitHub org somewhere. So you can actually look at how we built this thing. But if you want to enter the Raffle contest, all you have to do is go over to this URL at the bottom left-hand corner of the screen and sign up, enter your email. We'll give everyone a few minutes to sign up for it, enter the raffle, and then we'll call up the winner. We're live streaming over here, and just want to tell all the live streamers we love you, but we're going to give away the raffle, give away the Echo to someone here in the room. So sorry about that. Anyway, I'll give everyone a few minutes, and yeah, so we'll give away the raffle, and then we'll do Q&A if anyone has further questions. So go ahead and answer.
There's computers.
Just a heads up, if you need to connect to the Wi-Fi here, just connect to the HeavyBit guest network, and the password is all lowercase, all one word, guest bit.
All right, has everyone had a chance to enter? I'll give you another minute. Okay, 2 minutes. 2 minutes. While that's happening, this is the actual repo of the Raffle app. It's open source, and it is also a React application with a service inside. And really all we're doing is it's run through 2 API gateway endpoints. And yeah, there's instructions on how to run this in the repo. The URL for the Raffle is serverless-Raffle. Raffle.surge.sh.
Can I enter multiple times?
No, and if you've entered multiple times, we'll know about it. Because of GraphQL.
Kick you off.
All right. And this is we just renamed this today to the Raffletron 5000. I hope you guys like that name. It's very near and dear to my heart. All right, 10 seconds. Okay, so that's, all right, still waiting for one person. So I'm going to show you guys some more of the project. So yeah. Okay.
We're just going to enter for you, or we'll hand it to you when we have the form. Thanks for your cell phone, by the way.
Yeah. You donated it to a good cause.
It's an old one.
I always like to see how fast the room clears once we give away the echo. We're still going to do the Q&A after this, so if you have questions for Brandon, Nikila, Nick, Philip, or anyone, just hang around. What's your name?
Okay.
Howard. Howard, what's your email?
First name.
Okay, gotcha. You're in.
Thank you.
If you win, it's going to look like you rigged this. All right, David, let's do this.
All right, let's do this thing. The Raffle. So if we just go to the Raffle route. Okay, are you guys ready for me to spin the wheel of destiny? Okay, here we go. Hold on to your butts. Hey! Who's that? All right. Now what is your name, sir? What is it? Congratulations.
Awesome. You got to come and take a photo.
Yeah, yeah. Here we go. Smiles.
Thank you.
All right. Just to prove it isn't rigged, I'll spin it again, but you don't want anything. Cool.
All right, awesome. Okay, let's do a Q&A. I'll just run around. If anyone has a question, I'll go up to you. David? I'm throwing you under the bus for this one. I gotta do a refresh, okay? That's React state, okay? All right, if anyone has a question, just raise your hand and
So I have a question to the serverless team. So you guys are talking about deploying
obviously your serverless projects. Does serverless do anything, or is there any like conversation to like mitigate breaking changes between serverless projects or within serverless projects within the time that it might take for a Lambda or multiple Lambdas to deploy, whether in the same project or across projects?
Do you mean about like when you deploy a new Lambda, that like the phase between?
Yeah, like say you have a contract between Lambdas.
Yeah.
And you want to deploy them maybe together at the same time. Obviously, there might be.
Absolutely. Okay. So the question is about like if you deploy Lambdas together, how does it work with the contract? So we don't control that part because it's AWS. And in the end, what you have to do is like what you have to do with any kind of immutable infrastructure. You have to two-phase deploy. So if you want to deprecate something, you basically add the stuff before to deploy it, and then you deprecate it. That's the only way to go about it. But maybe if AWS adds more features and like lets us control more part of the deployment phase, then in the future, then we can do something about it. But right now, it's AWS. Yeah.
So I had a question for Brandon, and it was about the private and public schema running the same problems that you're running. And yeah, we are not sure exactly what to do. It looks like some people are returning null and the public not accessible. That kind of doesn't sound great. And you were mentioning that you only had a few fields that ended up being private. Maybe you could build a little bit more on it.
Actually just got this question a moment ago as well. So what we ended up doing, it's kind of an imperfect solution where we have all of our schema defined in one place once, and we built the ability to basically take any field type or connection and set a target for it. So a public target, a private target, a staff-only target. And effectively what we do is at on the server, we will then visualize once each copy of the schema for that particular target. And every query internally on the server side basically instructs the platform code like exactly which target they're using. It's imperfect, I say, just because rather than sharing these types and then building up a copy of the schema and excluding things just because of the particular open source library that we're building on, we actually take the built schema and then unwind things out of it. So actually delete fields out of it, etc. It's very, we kind of ran into this problem mainly because nobody else is really running into this problem. Most people kind of treat the schema as this immutable thing. And we're actually dabbling around with some dynamic permissions as well. Effectively tells the schema not this immutable thing. The definition is this, it exists in one place. You know, at even a field level, we decide what actually goes into the final copy of the schema build. It's kind of interesting. There's actually some things that I would hope that we can contribute back to open source on those lines as well. We want to improve how we're doing that in the next few months. But it is definitely a headache. One thing we have talked about internally, kind of along the lines of what you were saying, is create not a null type, but create a type that basically signifies that this thing could be loaded for one reason. We probably wouldn't use that for excluding private parts of the schema, but what we were thinking about using that for is like service information. Like, let's say right now we can give you the repo, but I can't give you any more information about the user, your avatar, or something like that. So instead, I'm going to give you back this object that just tells you that your query was correct, but it's a partial response for whatever reason. So that's one thing we're thinking about. But at the moment, we kind of have this imperfect, a little bit too brittle schema targeting kind of system built.
Oh, we got a celebrity in the house here. This is Jeff Meyerson, the host of Software Engineering Daily. He just moved to San Francisco. How long ago? 3 weeks ago. So if anyone enjoys as a podcast, as a fan of that podcast, you should come up and say hello and buy him a beer later.
And full disclosure, Austin is the sponsor of the show. So I'm curious if you get any disadvantages from putting the GraphQL server in a Lambda, because if there's anyone like caching or something that you get out of GraphQL is actually on a server rather than a transient function.
So the question was like, oh yeah, it wasn't mine. There's multiple ways how you go about it. So one way, there's a project from Facebook especially for the JavaScript side, which is called Data Loader. And Data Loader allows you to cache parts of the queries. And there's different ways how you do caching, and one way of doing caching, and that's mostly the recommended way, or the way we see it a lot, is like cache per request. Because if, for example, you fetch a friend, and then you fetch the friends of your friend, you don't want to fetch the same person or the same friend again, same data. So Data Loader understands like what person, what details you're fetching, and you can do this based on like per request basis. This is super useful because then with Lambda you don't have issues at all. It's a bit tricky because if you want to enable this, you also can enable the caching mechanism across requests, and it works on Lambda as well. Because what happens actually to Lambda is like AWS will to run the process again. Same, or you hit the and it starts. That's how it works. So we could even turn on caching across requests, but you run into the problem of like you absolutely have to make sure you don't show data from one user to the other, and that's really tricky. So what I've seen mostly is that people just use Data Loader, turn on caching, but on a request basis, and that helps a lot. And then have caching basically in your backend service to make sure that works, because there you have a lot more control, or your team has a lot more control with memcache, Redis, all that kind of stuff. Did that answer the question?
Yeah.
Cool.
All right, one last question, then you all have to chase these people down yourself.
Question for Nikia. In your architecture, how did you handle testing? I mean, different level of testing, unit tests, integration tests, system tests. Was that a challenge for Lambda?
Yeah, definitely. So we had unit tests per microservice, so per Lambda function, and then we had to run integration tests across the entire architecture. So as I mentioned before, a single request can trigger so many different Lambda functions. That's really important to test because otherwise it's really difficult to isolate where things went wrong. So we actually, as well as having tests, we built this logger module where we could send the logs to Kibana, and then we could search much more effectively and track errors much more effectively rather than just looking at the logs in CloudWatch. Because for debugging becomes a really big problem when you have such a complicated architecture.
All right, I think we're going to wrap for questions, but these people are going to hang around for a little bit, I think. So feel free.